inequality, you have x plus 1 times x minus 5 is greater than what? 0?
Yeah.
So what do you make? You make the what? Number line like we did in class? And what? You could, or you could just solve it. I mean, you can just solve it straight off. Like x is equal to what? When they're equal. So if we're going to solve this, if we wanted to solve x plus 1 times x minus 5 equals 0, what does x equal? -1 or 5. So those numbers are going to be -1 or 5. So how many regions do we have to test? 3. 1, 2 of them, and 3. So pick a number in each of those regions. What's between -1 and 5? That's really nice.
0.
Yeah, 0. How about -2 and 6? So what you do is you need to test that in this function right here. You let f of x equal x plus 1 times x minus 5, like we did before. And then you're going to do f of -2. That's going to be -2 plus 1 times -2 minus 5. That's going to be -1 times -7, which is 7. So it's positive right there. And then you do f of 0, which is going to be 1 times -5. What's that going to be? -5. So it's negative right there. And then you have to do f of what? F of 6. So that's going to be 6 plus 1 times 6 minus 5, which is 7 times 1, which is 7. So that's going to be positive. So to answer this question, where is this greater than 0? Can someone tell me where this is greater than 0? When x is less than, nope, -1, or when x is greater than 5. Done. There's your answer right there.
What's the other way to write that when you're like x is in between?
Oh, you could say, well, there's no other way to write that one because there's nothing that's in between. You could write it as -infinity all the way to -1, union 5, infinity, like that. Is -1 in the set? Do you remember, what is this called? This is called interval notation. It's the same thing. It's the same answer. Same idea.
I don't understand. How could something be less than -1?
What? Or. It's or. Either one. One or the other. What does this look like when you graph it, everybody? It looks like this. It's -1 and what? 5? What does this function look like? It looks like this, right? Where is this greater than 0? It's greater than 0 here, right? And it's greater than 0 here. What are the x values there? The x values there are less than -1 and or greater than 5.
Well, what about the middle?
Less than 0. Less than 0. That's the whole place where it's less than 0. We're only looking for it when it's greater than 0 on this one. Greater than 0. Yes. What is different about 27? What's different about 27? Yeah, there's 3. But what's one thing that's nice about 27? It's already what? It's already factored. Is it really nice when it's already factored? Yes. Especially since, do you guys really know how to factor cubics yet? No. So in this case, if you were to solve the equality, Jen, if you're going to solve the equality, what are all the x values? X is equal to what?
1, 2, 4.
1, 2, and 4. So you take your number line, and what do you put on it? 1, 2, and 4. This is the x value, and you're looking for the f of x. Is it positive or negative? Now, there was another set of numbers we could place on the line. Do you remember what that other set of numbers we needed to always look for? There were other numbers that could appear on this before we make all the segments. Do you remember from yesterday or the last class? We had one that looked like this. Do you remember that? The numbers that aren't in the domain. The thing is, though, this function right here, Liv, this function right here, what's the domain of this function?
X such that x can't equal.
No.
No.
Is there any division in there?
No. So
Is there any square roots in there?
No.
No. So therefore, what's the domain? All real numbers. So are there any other numbers to put on that line? No.
How do you know it's all real numbers?
Because there's every single number you can. Is there any division? What are the two things you can't do? You can't divide by 0, and you can't take the square root of a negative number, or you get an imaginary number. Is there any division in that? No. Any square roots? No. So therefore, what's the domain? Because there's no illegal operation possibility. So are there any other numbers to add onto this number line? No. How many regions do you see, Nick? Yep. 1, 2, 3, and 4. So we need to pick numbers in each place. What are we going to, I don't know, how about 0, What should we do right there? So 3 over 2. What about there? 3. And what about here? 5. Now, we want to know each of those colors, do they output positive or what? Do we care what the numbers are? We just want to know if it's positive or negative. So I'm going to show you a quicker way to do this than what you've done before. Quicker way to do this. Mar, stand up. What happens when you plug in 0 into there? Is it positive or negative? Negative. Plug 0 in it. And here it's. So when you multiply a negative times a negative times a negative, what do you get? A negative. Let's plug in 1.5. Is it positive or negative first? It's positive. What about here? Negative. What about here? What's a positive times a negative times a negative? A positive. What about 3? Oh, it's going to be positive, and positive times a negative is a. And 5 is going to be positive, positive, and. Now, you see how it alternates? We're looking at the product here. That's what we're looking at. You see how it alternates sign? Is it always going to alternate sign? No, it could be positive, 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 or negative, negative, positive, positive. But look, what does this tell us? We just figured out, did we figure out the exact numbers? No. This is going to be negative, this is positive, this is negative, and this is positive. And we're interested, where is this function less than 0? Can someone tell me where is this function less than 0? Jen. So you could say x is less than 1, or what's the other one? Can someone tell me the other one? What's the other place where it's less than 0? Alex. X is less than 4 and greater than 2. Correct. This right here would be your answer. What's another way you could write that? You could do negative infinity 1 union what? It's kind of hard, yeah. 2, comma 4. I'm basing it off of the product because we're multiplying the three things together. So look at the product here. Negative, positive, negative, positive, negative, positive, negative, positive. We figured out the sign. Do we need to know the actual number? No, we're just interested in the sign, positive or negative. We're just interested in the sign because what is this one asking? Where is it less than 0? Did we find out where it's less than 0? Yeah, it's less than 0 here at the purple, right there. Right here. There's where it's less than 0. And where else? What other color? The blue, between 2 and 4, right here. That's where it's less than 0. It's where it's less than 0. Yes?
Shouldn't this one, shouldn't it be the other way since it's greater than 2?
It is. It's from the perspective of x, Mar. From x's perspective. Is x greater than 2 here? Yes, because 2 is less than x, how it's written right there. In that inequality, take a look at this right here. What's the relationship between 2 and x? 2 is what?
2 is greater.
No. 2 is. This means less than. 2 is less than x. So that means x is greater than 2. This is a compound inequality. This means x is less than 4 and x is greater than 2. Why does it have an answer like this? It has an answer like this because what were those zeros? 1, 2, and 4? Those were the zeros of this polynomial. Was it 1, 2, and 4? 1, yeah, it is a wavy graph. That is correct. 1, 2, and what? 4. And it's less than it. Where is it? It's 0 at each of these places, right? And it goes negative, positive, right?
Yeah.
What does this graph look like? It actually looks like this. See this? It's got 2 turning points. How many vertices do you see, or how many vertexes do you see? There's 2 vertexes. So where's this thing negative? It's negative right here, and it's also negative right there. What is this region right here? X is less than 4 and greater than 2. What region is this right here? X is less than 1. Exactly. Now, are finding these vertices sometimes really important right here?
Yeah.
Absolutely. Can we do that in this class? No, because parabolas are nice because they're symmetric. You can sit down now. Parabolas are nice because they are symmetric. Are these symmetric curves? No. Like if I folded it right here, are these going to overlap on both sides? No, they're not. You need calculus to find these points. You spend half your time in calculus studying rates of change. If you were on a roller coaster, and this was your roller coaster right here, what would it feel like at this point right here?
It's really
What would it feel like? What do you feel? Who's been on a roller coaster? Yeah, how does it feel when you're at this point? Oh, butterfly. Why? Because you're not going up or down. It feels like you're floating for a second when you're at the top. When you're going up right here, but then the second you pass this spot, you're going down. So are you traveling up or down at this point? No. So finding that point where the vertical rate of change is 0, half of calculus is studying rates of change. Half of calculus is finding areas and volumes of things. And both of those things are super important to real life. Super applicable. Okay, so if you write this as an equality, everybody, if you write this as an equality, what are the 3 possible answers? Someone raise their hand and tell me one of them. X is equal to what's one of them? Liv. Someone new for the next one. Connor. 3/4. And what's the last one? Milo. What? -7/2. Yes. So put them in order on the number line. And what do you have? -7/2, -2, and 3/4. So how many regions do you have? 1, 2, 3, and 4. So you need to, how many values should you check? 4. So maybe -4? Yeah. -3, 0, and 1. That's what I would check. That's what I would check. So you can put them in order if you want. It doesn't really matter. But so you have your x value. And what was the factored form here? You have these 3 things, right? That's the factored form. Remember that chart? Remember the chart we made? Is that helpful to use in this case? Yeah, it really is. So what do you have now? You take the x plus 2. That's one of them. You take your 4x minus 3. That's your next one. And then your 2x plus 7. Then what do you put last? Product. So what are the x values? -4, -3, 0, and what? 1. When you plug in those values, -4, when you plug these in, what do you get? Everybody stand up. So, who wants to read the first line to me? Who wants to read the first line? Liv, what is it? Yep, and you get a negative. Who wants to do the next line for me? Next line. Shane, do the next line. When you plug in -3, what do you get for signs? Yep. Nope. Yep. No. Plug in -3. What do you get into that, Shane? Yes, you get positive. So when you multiply them all together, what do you get? Positive. So you're multiplying all 3 of these, and you get that one. You multiply all 3 of those, you get that one. Who wants to do the next line? Mar, what is it?
Positive.
Yep. Negative, yep. And? Positive. So when you multiply them all together, what do you get? You get negative. Yeah, exactly. And Zoya, what's the next one? What is it? Plug in 1. What do you get?
Positive.
Yep. Yep. And? Yeah. So now can you fill in that chart that you were working on? Oh yeah, it's going to go, what does it go? It goes negative, positive, negative, positive. So now you look at your inequality. Where is it greater than or equal to 0, Aubrey? Can you tell me one place where this is greater than or equal to 0? It's right here, Aubrey, on the board. Look.
I thought -2 is less than x when it's greater. How do I say it?
You say x is less than -2 and it's greater than -7/2.
Yeah.
Or, can someone tell me the other one? What's the other place where it's positive? Summer, what is it? X is what? Correct. And there's one thing that's wrong about this that's not quite finished. Can anybody tell me what we're missing? Liv, what are we missing? Yes, because what does it say right here? It has an equal on it, right? So you want it to be equal to 0 as well. So this is your answer right there. Because this, when x is less than -2 and greater than -7/2, is right there. Or when x is greater than 3/4 is right there. Okay, and sit down, please.